Right, let's start off with the light phase, also called the light dependent phase. Very important for you to know its alternative name is because this phase of photosynthesis depends on light. So therefore we have to also call it the light dependent phase or the light phase. This takes place in the grana, which contains chlorophyll. So if you look at your diagram, can you see that in one of the grana, they have it expanded and the word H2O and photolysis is written inside there. So I must know that my light phase takes place inside that structure here, right? Light phase is taking place here. Or I can call it light dependent phase is taking place inside my grana, inside those stacks of your thylakoids, right? So we're going to start off with the radiant energy. As you can see, it's depicted by like a lightning bolt, and we've got light energy or radiant energy that obviously falls onto this grana through your transparent membrane. Once it's inside that grana, remember that your chlorophyll inside the grana is going to absorb this radiant energy. So it's energy now in the form of light. Okay, the energy has the ability to cause change or to do something. So we're going to utilize this energy inside your grana, right? Because your chlorophyll is doing the absorbing of it. It's a green pigment, remember that, right? So this energy that is now absorbed by a chlorophyll inside your grana, what it does is it actually excites electrons inside here. And when it does that, the energy that is now produced is used to form ATP. So I'm going to write there, energy used to form ATP in the light phase. That happens because of the radiant energy that has excited electrons inside this chlorophyll, inside the molecules that is there, right? That energy is important also because the water that enters, remember, water is a requirement for photosynthesis. So water as one of the reactants is now going to be used in this process. Let's just write this down here so that when we are doing both phases, you can put a tick next to each one to say, okay, we've used that, okay, we've used that. And you must be able to see the entire equation play out inside here, right? So we're going to get C6H12O6 plus 6O2, right? And we want to write the words light energy, we want to write chlorophyll, and we want to write enzymes and coenzymes, right? That's there. So let's take water, right? Water obviously enters, it's a reactant, it will enter through the permeable membranes of the inner and outer membrane of your chlorophyll, enters this chloroplast, and it's going to be utilized in the light phase, because in the light phase photolysis takes place. So you can see inside your grana you've got H2O in a pink block with the word photolysis, right? So basically photo, light, lysis, to split. So the energy here in this phase, right, is actually used to split hydrogen from oxygen. Now, it's not just one oxygen molecule that is being used in photolysis. It's many water molecules. It's not just one water molecule that's used in photolysis. It's many water molecules. So therefore, when we show you that H2O splits to become O2 and to become H, do not try to figure out how, okay, why is it O2? It wasn't O2 there. No, that's because it could have been many water molecules like 2H2O, right? So then in this instance, there is 2 oxygen molecules there. So let's just stick to the elements that are there. Hydrogen and oxygen are there, okay? So photolysis takes place because radiant energy is absorbed by your chlorophyll. Photolysis means the splitting of water using light energy. Photolysis, lysis is split. So oxygen is then split from the hydrogen, from this molecule of water or molecules of water. The oxygen is released through your permeable membranes, and that becomes the byproduct, isn't it? Bye-bye, it's going, let's tick oxygen, right? It's released. It's not required. It's a byproduct, and that's how you get the oxygen that is released in the atmosphere. By the way, when that oxygen is being released from the leaf, right, we know it's leaving this this permeable membranes here, but it also has to leave the leaf as well, isn't it? What structure does it leave the leaf from? If you recall, if you can recap, you know that that is the stomata, one stoma, isn't it? And they are surrounded by guard cells. Very important for you to remember: palisade mesophyll, spongy mesophyll, and guard cells. Those are the cells that contain chloroplast. It's not there in your study guide. You have to add it in, but we'll go there, right? So anyways, back to photolysis, light phase, using light to split up hydrogen from oxygen, right? Basically, when this chlorophyll absorbs that light energy, we say that the chlorophyll has become activated because the radiant energy has been absorbed into it. It becomes activated, like I said, the electrons becomes excited, and it's therefore able to form ATP, and the energy is therefore used to split the hydrogen and the oxygen. Right, oxygen is gone, and we have the hydrogen that is now going to enter the dark phase, or the light independent phase, because it is independent of light. So we must know dark phase or light independent phase takes place in the stroma. So stroma is dark phase, right? That's where it's going to take place. That means that this does not require light. So yes, it does mean that even at night, when there is no sunlight available for the plant, the dark phase of photosynthesis can continue to take place. So this hydrogen that is going to the dark phase, that came from the water, I'm going to put a plus sign next to it. That's because hydrogen is also high in energy. It actually becomes like an energy carrier. The energy that it gained from the light phase, because the light phase used light energy. So we can sort of say that hydrogen combines with the ATP, right, to become energized. Can you see it? It says here hydrogen carrier in that white block. Next to that white block, you can write down energized hydrogen carries energy for dark phase in the stroma. Right, now we've got this hydrogen carrying this energy, hydrogen carrier, enters the dark phase in the stroma. Remember, in your stroma, there are enzymes and also coenzymes, right? The hydrogen atoms here actually also combine with coenzymes in the dark phase, right, in order for this reaction to take place. So I've got enzymes here because they are produced from the ribosomes that are in the stroma. So in this dark phase, the energy carried by the hydrogen is going to be used to split and recombine all of these elements. We've got CO2. Where did it come from? I just wrote it there. It came from the atmosphere. It's a reactant, so let's tick here CO2. Ticked. We also got to tick light energy, right? And we've got to tick chlorophyll because it happened there in your random where the chlorophyll was. So the CO2 enters as a reactant, and yes, it's entering via this permeable membranes. And if it's entering the leaf, back down there, it's doing so via the stomata. But that CO2 has the elements carbon and has the elements oxygen. So this energy that is being carried by the hydrogen needs to be able to actually split the C from the O and recombine all of these elements with the H to give us a compound that has C, H, and O. C, H, and O. There's it there, glucose. Okay, it's going to give us glucose. But it has to be able to do that with the use of the energy from the hydrogen. So we'll say that ATP combines hydrogen with CO2. And not forgetting that the enzymes that are present, what do? They catalyze the reaction. What reaction? This very reaction here, H plus the CO2 is giving me C6 H12O6. Okay, anyways, you've got it written here, C6 H12O6, and you've got two arrows that is showing you where that glucose is going. It can be used by the plant, or it can be stored as starch in a starch grain. Let's put a starch grain there. Starch grain being insoluble, has to be broken down to release the glucose when the plant needs to use it. But what we must know that's important is that this glucose molecule has energy in it from the start. Through the light phase and the dark phase, we have now produced an energy-rich compound called glucose. And it's important for us to know that because when we look at respiration, we are going to see that one glucose molecule, when broken down, will be able to yield or to give 38 ATPs. ATP standing for adenosine triphosphate. Look on page 41. It is there. No, it's not there. Write it down. Page 41, towards the bottom half, you have role of ATP in the cell. The word is adenosine triphosphate.